All right, in a proof, what you need to do is prove that the left-hand side is equal to the right-hand side. So you're going to pick either your left-hand side or your right-hand side. And because of our angle sum or difference identities, it's probably easier to pick the left-hand side, expand it, and try and make it look like the right-hand side. So there's a bit of a format that you need to set your proof out in. So let's start. Required to prove that sine of a plus b sine of a minus b is equal to sine squared of a minus sine squared of b. And I'm going to pick my left-hand side, which is sine of a plus b sine of a minus b. And I'm going to go and look at my formula sheet and see that I have got identities to expand sine of a plus b as well as sine of a minus b. So I'm going to say, using sine of a plus b is equal to sine of a cos of b plus cos of a sine of b, and the other one, which is my sine of a minus b, is going to be sine of a cos of b minus cos of a sine of b. And I'm now going to substitute those in. Give yourself some space. So what we've got is sine of a cos of b plus cos of a sine of b times sine of a cos of b minus cos of a sine of b. Now, this is a sum and difference, so if you could see that immediately, you could go straight to your difference of perfect squares. Otherwise, you're going to expand that using FOIL, and you're going to have that sine squared of a cos squared of b minus sine cos a cos b sine b plus sine a cos b sine b minus cos squared a sine squared b, and obviously the two center terms cancel, and we have sine squared a cos squared b minus cos squared a sine squared b. Now, that's not too far off from the sine squared a minus sine squared b, except that I've got these cos squareds over here. But I know that there's another identity that I can use, which is my Pythagorean identity, which says that cos squared of b is just going to be 1 minus sine squared of b, and cos squared of a is just going to be 1 minus sine squared of a. So I can then say sine squared of a times 1 minus, sine squared of b minus 1 minus sine squared of a times sine squared of b. And I'm going to need to expand that. So I've got sine squared of a minus sine squared a sine squared b. Follow the process. Sine squared b minus, and then I expand this, sine squared b minus sine squared a sine squared b. And when I expand my negative, my sine squared a sine squared b's cancel, and I get sine squared a minus sine squared b. And how awesome is that? That's the thing I was looking for. So that's equal to my right hand side. So I can say therefore sine of a plus b minus b is just equal to sine squared a minus sine squared b.